All right, Year 11, I'm just going to go over what we did in class last lesson because some of you are away and some of you might have some trouble with these. I'm going to do a couple of the questions from 120 where we're working with surds and we're doing this activity. We are rationalising the denominator. Now, all that means in rationalising the denominator is that we're going to get the denominator to be a rational number. Now, that helps us with solving or simplifying algebraic fractions with surds in them, which is what this is all about. So rationalising, making the is a number that can be written as a fraction or a whole number, so not a surd, and we're rationalising the denominator. We're going to be using this rule, which is when you multiply the same number, like root 3 times root 3, you get 3. When you multiply root a times root a, you get a. So let's have a look at the first one, and it's 1 on root 7. And this one's pretty easy because all I've got to do is multiply by root 7. But we know when we're dealing with fractions that if we want to keep the fraction the same, we multiply top and bottom by the same thing. Essentially what you're doing is multiplying by 1. You're not changing the fraction, you're just rearranging it. You're changing the way it looks, not its value, which is a good thing because it means you can check any of these questions in an exam by just typing it into your calculator, and I'll show you that in a minute. So we multiply by root 7. On the top, we get root 7. On the bottom, we get root 7 times 7, root 7, which is just 7. And that one's done. Let's do B. We'll do it rather quickly. It's pretty easy. Root 3 on 2, root 2. Now, the first thing you've got to understand, don't go multiplying by any other numbers, just the surd. Don't multiply by 2 root 2, just multiply by the surd. That'll get rid of the surd on the bottom. If you multiply by 2 root 2, it'll also get rid of the surd on the bottom, but then you'll have to simplify. We want to keep this as simple as possible. So we're just multiplying by root 2 because that's the only surd in the bottom. On the top, I get root 2 times root 3, which is root 6. And on the bottom, I get 2, and root 2 times 2 is 2. So I get root 6 on 4. Okay, so most of those you can do. I'm going to jump to the last one, which is J. You can do the ones in between, they're not too hard. I've got 4 root 3. 4 root 3 minus 2 root 2 all over 7 root 5. Again, I just look at the denominator and I just go, I'm just going to multiply by root 5. Don't worry about the 7. You don't even dare look at the top. The top's got nothing to do with it. So we'll do the top first. What do we got? 4. So we've got two things. We've got that times root 5 and that times root 5. So 4 times 2 is 8. Root 3 times root 5 is root 15. So I get 8 root 15. Oh, silly. Sorry. What am I talking about? I multiplied the wrong things there. 4 times 1 is 4, because there's a 1 in front of that. And root 3 times root 5 is root 15. Now, what have we got next? Minus 2, and root 2 times root 5 is root 10. On the bottom, I get 7 times 5, because the root 5 cancels itself out. So I get 4 root 15 minus 2 root 10 over 35. So that's all I have to do. Question 1's rather easy. Question 2 is where we have issues. Now, if you look at the first one, I can't multiply by root 3 because it'll get the surd out of the root 3, but it'll make the root 2 6 because I've got to multiply everything by whatever I multiply. And I can't multiply by root 2 because that'll just make the first term, the root 3, into root 6. So I'm going to use this law, which you've seen before, which is a plus b times a minus b. And we should know by now that that's the difference of two squares. I'm not going to go and prove it. You can go back and check. We've proved it in class before. And that'll be okay. And what we call this is multiplying by the conjugate. And the conjugate is just the thing that will give you the two squares. Because sometimes it will be minus. Well, look at this next one. It's root 2 minus 7. But that doesn't matter because the conjugate will just be the same thing with a different sign. The conjugate is just the same thing with a different sign in the middle. And if you remember that, you're going to be fine. So let's jump into these. So we'll do the first two and then I'll do F. And you can try the ones in between. So 2a, what have we got? 4 on root 3 plus root 2. 4 on root 3 plus root 2. What do? We look at the bottom. We look at the denominator because we're rationalising the denominator. Don't worry about the numerator. So the bottom, we need the conjugate, or it's just the same thing, root 3, root 2, but we change the sign. It's minus. And we do the same to the top because remember what we're doing is we're multiplying the whole fraction by 1. Okay, so that gives me on the top 4 times root 3 and 4 times root 2. So I get 4 root 3 minus 4 root 2. Now on the bottom, all I get is that squared minus that squared. Well, root 3 squared is 3 minus root 2 squared is 2. And when you look at that, 3 minus 2 equals 1. And we all know that when we divide by 1, we don't need to write it. So it just becomes 4 root 3 minus 4 root 2. And that one worked out really easy. Now, let's have a look at b, because it's a minus. And we've got a surd on top, but we don't even look at the surd. So b, what have we got? Root 3. We don't even look at the numerator, I mean. And root 2 minus 7. And you think to yourself, it's a whole number. I don't have to worry about it. I just multiply by root 2. No. If you multiply by root 2, yes, the root 2 will go, but you'll get caught with 7 root 2 in the denominator. You won't have rationalised it. So you must apply the difference of two squares. So we're looking for the conjugate. And you remember, it's the same thing with a different sign. So this time it's plus root 2 plus 7. Okay. On the top, root 3 times root 2, root 6. 7 times root 3, 7 root 3. On the bottom, remember, it's this squared minus this squared. Okay, root 2 squared is 2. 7 squared is 49. And there's a minus. Okay. Root 6 plus 7 root 3 on negative 47. Now you could leave it like that. Common practice is to put the negative out the front. If you do that though, just beware that your negative sign or your minus sign might not be as neat as you would like, and it might go up a bit. And people might think it's minus root 6 plus root 7 root 3. Whereas you want that negative sign right out the front. So it's a good thing to put it in parentheses. Okay, let's go to question F. Now F, 3 root 3 plus root 2, 3 root 3 plus root 2, 2 root 5 plus 3 root 2, 2 root 5 plus 3 root 2. Double check because I got this wrong earlier. 3 root 3 plus root 2, 2 root 5 plus 3 root 2. Righto. Again, you've got a subtraction or an addition in the denominator. Here we've got an addition. We are going to multiply by the conjugate. You just write the same thing. 2 root 5, but change the sign. 3 root 2. And you've got to multiply the top by the same thing. Look at that. 2 root 5 minus 3 root 2. Okay. Now I'm going to do the bottom first. It's the easy bit. And again, it's that squared minus that squared. Now watch how I do this. 2 squared is 4. Root 5 squared is 5. 4 times 5 is 20. 2 squared is 4. Root 5 squared is 5. 4 times 5 is 20. The next one. 3 squared is 9. Root 2 squared is 2. 9 times 2 is 18. So my difference of 2 squares is 20 minus 18. On the top, I've got 2 things by 2 things, so I'm going to get 4 things. That by that, and that by that, and that by that, and that by that. Here we go. 3 times 2 is 6. Root 3 times root 5 is root 15. So I'm going to have 6 root 15. The next one, 3 times 3 is 9. Root 3 times root 2 is root 6. So minus 9 root 6. The next one, 2. So I've got a plus 2, and root 5 times root 2 is root 10. And the last one, root what do we get? Root 2 times root 2 is 2 times 3, I'll get 6. Now, 6 root 15 minus 9 root 6 plus 2 root 10 minus 6 all over 2. Don't try and add any of those terms in the top. None of them are like terms. They are all different terms. You can't add them together and you can't simplify it. That is the answer. Usually we try to write the non-cert out the front, but because it's minus 6, we'll just leave it where it is. Okay, so you need to do those questions in 2. They're just rationalising. When you get to question 3, you've got to do some rationalising before you do your adding or subtracting. So I'm going to do A and E, and you can have a crack at the other ones. They're hard and they'll take you a bit of time. So 3A, and what have we got? 1 on root 2 plus 1 plus, hold on, I'm going to leave a gap there. And I'm going to have to write this down a bit further. So 3A, 1 on root 2 plus 1, and is it minus or plus? Plus 1 on root 2 minus 1. Now, you can see I've left a gap there because I'm going to put the conjugate in straight away. because you need to rationalise it first. Don't try and get a common denominator first. In this case, it works out the same way, but not always. So I'm going to multiply, look at the denominator, root 2 minus 1, root 2 minus 1. And this one, I'm going to rationalise, and I'm going to get root 2 plus 1 on root 2 plus 1. Okay, so equals. Do the first one. The top line's easy, root 2 minus 1. And on the bottom, I get the difference of two squares. Root 2 squared is 2, 1 squared is 1. I get 2 minus 1. And I've got here, do the top, root 2 plus 1. And on the bottom, root 2 squared is 2, 1 squared is 1. And it just so happens, root 2 minus 1 plus root 2 plus 1. And they're both over 1, which I don't need, because anything divided by 1 is itself. So it's root 2 plus root 2, 2 root 2. And minus 1 plus 1, they just cancel each other out. So that one was a pretty easy one. But let's go to E. Now some of you will be tempted to make the common denominator of root 6. You can do it that way, but can I advise you against doing it, or you're learning that method, because it can get you into trouble. It just gets messy. So for example in G, actually let's do G. I'll do G instead of E, because if you try and make that a common denominator first, you're going to get ugly, and it's easier to rationalise both those fractions first before you add or subtract. So root 5 on root 6 plus root 2, is that right? Root 5, root 6 plus 2. So here we go, 3G. Root 5 on root 6 plus root 2. I'm going to leave a gap there. And 2 on 5 root 3 minus 2 on 5 root 3. I'll leave a gap, minus 2 on 5 root 3. So here, I multiply by the conjugate, root 6 minus root 2, and root 6 minus root 2. And here, I just multiply by root 3, because there's no conjugate. There's no adding or subtracting. So the first one, root 5 times root that, and root 5 times that. So root 5 times root 6 is root 30. And root 5 times root 2 is root 10. It's a separate fraction, and then I get that squared minus that squared. Well, root 6 squared is 6, root 2 squared is 2, 6 minus 2. In the second one, I get 2 root 3. And here, the root 3's become 3, and 3 times 5 gives me 15. So, root 30 minus root 10 on 4 minus 2 root 3 on 15. Now, I need to find, okay, common denominator. I'm looking at the answer and I'm a bit worried because I may have written the question down wrong, because, look at that. It's not root 2, good. It's just 2. So let's fix that up. Sorry everybody. And I'll just fix this up. So that's 2 root 5. And now, down the bottom, I get 6 minus 4, which is 2. Excellent. Sorry about that. That makes more sense. Okay, so now I have to find a common denominator. And the common denominator is going to be 30. So I'm going to multiply this by 15, top and bottom. I'm going to multiply this by 2, top and bottom. So what do I get? 15 root 30 minus 30 root 5 all over 30. And here I get 4 root 3 on 30, which gives me 15 root 30 minus 30 root 5 minus 4 root 3 on 30. Now, that's A. Did do B, didn't I? 3B. A and G in question 3. The ones I really want you to do, I'm not too fussed about 5 and 6, but the ones I'd really like you to do are C, D, and E from question 4. These are the important ones because that's how they tend to ask them in the HSC. So I'm going to do C and E. You make sure you do D. Should try and have a go at them yourself, but I'm going to do them here so you can go away, try them, and then come back and have a look. So 4C. Now 4C. And it says it wants you to make 2 plus root 5 on 1, or 2 on root 5 plus 1, and they want you to get it in the form A plus B root 5. A plus B root 5. So what you do is you're just going to take that left-hand side and you're going to go, well, 2 on root 5 plus 1, and I'm going to multiply by the conjugate. I'm going to rationalise the denominator. I'm going to go root 5 minus 1, root 5 minus 1. Now the bottom's pretty easy. Root 5 squared is 5 and 1 squared is 1. On the top I'm going to get 2 root 5 minus 2. Okay, that gives me 2 root 5 minus 2 on 4. Well, I'm going to factorise out 2, which gives me root 5 minus 1, and 4, and I'm going to cancel. 2 goes into itself once, 2 goes into 4 twice. So what I've got now is root 5 minus 1 on 2. But when you have a fraction, let's say, for example, you had 7 plus 3 all over 5. Well, that's the same as 7 on 5 plus 3 on 5. Well, I'm going to split this now. I'm going to have root 5 on 2 minus 1 on 2. And if I wanted to be really tricky, that's a half root 5 minus a half. And remember, what I needed to get it to look like was A plus B root 5. Well, I can write that as a half root 5 plus negative a half. Now it doesn't matter which way I add them. So I get negative a half plus a half root 5. So A equals negative a half and B equals positive a half. And I'm just checking the answers. And that's right. So there's a couple of tricks there. You've got to rationalise it. You've got to write it as separate fractions. And then you've got to do the old switcheroo. Now, for 4E, I want you to go and have a go at it yourself. All right, so they want, and I want you to do D by yourself, and we did that in class, so it's on the website, on the board, on the photo of the board work. But E's a little bit different, and they don't usually ask it this way, but I'm going to do it anyway. You go and have a go at it. You might just get stuck at the last step. Anyway, E, so 4E, what do we got? Root 2 plus 3, root 2 minus 1. So, root 2 plus 3, root 2 minus 1. And they want us to write it as A plus root B. Let's just double check that. Root 2 plus 3, root 2 minus 1, A plus root B. Okay, so this is for, what do we say? B. Okay, so I am going to multiply by the conjugate. That's pretty easy. Root 2 plus 1 and root 2 plus 1. Now, what do I get? The bottom's easy. The square of root 2 is 2. The square of 1 is 1. 2 minus 1. This is looking a lot easier than I thought. But let's do the top. That times that, that times that, that times that, that times that. I'm going to get 4 terms. How are this going to work out? You watch. Root 2 times root 2 is 2. Root 2 times times 1 is 1 root 2, or just root 2. Root 3 times root 2, 3 root 2. 3 times 1, 3. So what do I get? 2 plus 3. Oh, look at this. 2 plus, get back here. 2 plus 3, they're like terms. 2 plus 3 is 5. And 1 root 2 plus 3 root 2 is 4 root 2. Now that's all over 1. And you're thinking, oh wow, 5 plus 4 root 2. But they want this bit written as a whole surd. So I've got to put that 4 back in. So that's 5. And the root and the 4, well, that can be written as root 16 times root 2. And that'll give me 5 plus 2 16s, root 32. So my A equals 5 and my B equals 32. Let's just see if that's right. And it is. Now, the last thing I wanted to show you was where is it? How to check it on your calculator. And I can't get my calculator because, oh, there it is. I don't want that. I just want the calculator. I don't want that. Cancel. Right, get out of here. Right, we'll just go back here. I'll tell you how to do it. All you do to check your answer. So say, for example, here, and you wanted to know whether or not what you started with, which was this, equaled this. You just put them in your calculator. You do the first one in your calculator, you get an answer, you write it down on your piece of paper, and you do this bit on your calculator and see if the two numbers are the same. You can always check surds when you're rationalising, when you're simplifying. Is what you started with the same value with what you finished? And if it is, you're right. Well, you might not have simplified it as much as you should have, but you're pretty close. At least you'll know whether or not you've made a mistake. Because if you get a different value at the end than what you started with, well, then you've messed something up. Right, you need to work on those and get them done before our next lesson, because we're going to be moving on. And I'm going to start with the rationalising in class of past HSC. Good luck.